Hello, folks. Thank you so much for joining me. I am going to do my usual thing of waiting a couple of minutes, or maybe 1 minute, for any late arrivals to join us. While we're waiting, I would love, as always, to hear where people are joining us from. So if you wouldn't mind just letting us know in the chat where you are dialing in from, I'd love to see all the different geographical locations that are joining us. Right now, I'm based in the UK, or I'm working out of the UK. Usually, I'm based on the west coast of the US in a small town called Birch Bay, up near the Washington and Canadian border. But I'm currently in the UK, so enjoying my family time. We'll wait just one more minute. Seeing a lot of awesome locations here. Somebody from Oxford, awesome, what a great place. Someone from Greece, what an awesome place to visit if you never had a chance to go there. While we're waiting for some late arrivals, I will do some housekeeping in a few moments, and then we can get started. I really appreciate everybody joining us. It looks like we've got quite a few people out of Europe, so people joining us late into the evening. Let me get my screen shared. We want one. Here we go. Perfect. I'm actually just going to quickly stop sharing my screen because I really need to sort out my window arrangements. So bear with me. There we go. Perfect. Okay, thanks everybody for joining us. I make it 2 minutes past the hour, so we're going to get started. We'll start, as always, with some housekeeping. Please be respectful in the chat. Remember that this is a public forum, and you should use words that are respectful to other people. This is a live webinar with live demos. I am going to be doing things live here, so I'm at the behest of the demo gods. Things may go wrong. I will troubleshoot them in real time. I will talk you through what I'm experiencing, why I think things have gone wrong. But I want you to think about this as just the standard work that I do as a solutions engineer at Tailscale on a regular basis. Things don't always go well. I really don't like those sort of webinars that are all slick and polished. I want this to feel as real as it possibly can. So I'm going to be real with you. The demos may go wrong. If you do have questions, somebody's saying I'm rocking the old YNAB client. Yes, I am indeed rocking YNAB 4. You can prize it from my cold dead hands. Please make sure when you are asking questions, there is a Q&A section in the chat. I have them up on the second screen here. They're a lot easier for me to get to if you ask them in the Q&A section. If they're in the chat, I may miss them. They may disappear in the scroll. So if you do have questions, please ask them in the Q&A. Please also ask them in a single concise question. Sometimes people will ask multiple questions and add-on questions. It's really helpful if you just write out the whole thing so that I can address it as we go along. I have my wonderful colleague, Alan, with me, who is also going to be picking up questions in there as well. So he'll be able to help man the chat for questions, but please, where possible, ask those questions in the Q&A. And then I usually provide a feedback form at the end of the webinar. I've decided not to do that. So you can see here, I've reused the slide from my previous webinar, added this bullet point on the end, and forgot to remove it. So yeah, there will be no feedback at the end of the webinar. If you do like what you see, please feel free to email us at se@tailscale.com, and that will come directly to our team. So with the housekeeping done, let's do a quick introduction. You may have joined a webinar with me before. My name is Lee Briggs. I have a GitHub repository with a name that I chose when I was 13 that is still in use as a professional. If you are interested in any of the things that you've seen today, it will all be on the GitHub. I also occasionally write on leebriggs.co.uk. I have made a conscious decision to remove myself from any social media platforms at this point. I won't share why, but that's generally just better for me. So if you do need to get in touch with me or you would like to discuss anything that you see on the webinar today, the best way to contact me is lee@tailscale.com, and would love to chat about any feedback that you have from the things that you see today. So what are we going to be talking about? Well, a lot of the inspiration for this webinar has come from the conversations that I have as a solutions engineer on a day-to-day basis with the organizations that are looking to adopt Tailscale in their enterprise. We've had a few webinars in the past that are focused on bring Tailscale to work and bring Tailscale to AWS. So what I've done today is this is an opportunity for me to share some of the repeatable patterns that I've seen in some of the larger scale Tailscale implementations. Some of the stuff that you may hear today is probably stuff that you might have already become aware of. But the most important thing that I think you'll get away from this is the fact that we've made these in a repeatable way. Lots of you as customers of Tailscale or users of Tailscale are likely all solving the same problems and doing it in your own repeatable way. I'm a firm believer in the commoditization of technology. And while you may be a competitor when it comes to your individual company's product, you don't necessarily need to reinvent the wheel when you're doing the same thing over and over again. So ultimately, what we're going to be focusing on is a lot of Terraform today. This is the most requested infrastructure as code tool that we hear on the Tailscale side. So if you are using another infrastructure as code tool, I would love to hear a little bit about that. I have a poll that's going to be coming to you any minute now. I would love to get an idea of which infrastructure as code tools that you are using and whether we can make webinar content focused on that infrastructure as code tool. I'm seeing these results come in. I've seen quite a few Pulumi people. As a former Pulumi employee and Pulumi user, I'm really excited to hear that. Lots of Ansible. I know that our wonderful developer advocate, Alex, does a lot of Ansible-based content. But it looks like the overwhelming winner so far is Terraform. So it seems that my decision to focus on Terraform for this webinar today is definitely the right one. So I'll let that poll run for a few more minutes, and then I'm going to send you another poll based on cloud providers. But ultimately, that is what we're going to focus on today. By way of an agenda, we're going to talk about the two main use cases that we generally see with Tailscale. That is Tailscale on every EC2 or every compute. Worth remembering that a lot of things we're going to be talking about today are AWS specific, but it is applicable to other cloud providers. But that is generally installing Tailscale directly alongside the applications that you're actually using and wanting to access. And then we'll talk about subnet routers and some best practices for managing subnet routers at scale. I have a couple of demos here with a couple of implementations that I think you can use yourselves right from day one. So these are kind of ready for you to use. And then we'll talk about how those repeatable patterns can be applied. And then finally, some common pitfalls. One of the great things that Alan and I get to do as part of our solutions engineering team is see all of the problems that people experience when it comes to Tailscale. So we have kind of a really first line experience to what that looks like. So it looks like Terraform won our infrastructure as code poll. I'm going to send one more real quick. I'm going to send your favorite cloud provider, and then we will talk a little bit about use cases. So use case number one is in any cloud provider is that you just install Tailscale into every single. Oh my God, I've got a typo in my slide. What a great starting point here. I'm definitely not going to get the demos right today. I can definitely definitely think I'm going to get some demo hell today. But one of the things that I really advocate for with customers is installing Tailscale directly alongside the applications on the compute that you're wanting to access. The primary benefit that you get from this is that you get to fully leverage Tailscale's ZTNA implementation and ACL mechanism to be able to very prescriptively and tightly decide who is able to access what when it comes to Tailscale. The most common way of installing Tailscale in these particular environments is actually using user data. We'll talk a little bit about containers later. I know that containers are everywhere. I did a Kubernetes-focused webinar a couple of months ago where we focused specifically on Kubernetes. I wanted to make sure that we didn't monopolize the kind of content that we're doing and focus more on the compute-based stuff today. Most of the time with customers, we see this implemented with user data and cloud config. And as I already mentioned earlier, one of the things that we see on the solutions engineering team is people using the same patterns over and over again. So what I've tried to do as part of my work here at Tailscale is start to commoditize this so that you don't have to constantly repeat the same things that other organizations are doing. Just as a quick aside, we got 50% of our users are using AWS. So 50% of the content we're focusing on today is very applicable. For those users that are using Google Cloud, Azure, or another cloud provider, all of those cloud providers support some form of user data. So you are going to have something that you're going to be able to take away from this. The second use case, which I think immediately comes to mind when you think about how the install Tailscale everywhere model is available to you, is that you can't access the operating system and you can't install software on most cloud provider services. RDS is a great example. Any managed database service that you would get from your cloud provider it's not possible for you to install Tailscale directly on that device. But you still need to be able to use Tailscale's remote access to be able to get to those things. And that's where our subnet routers come in. I'm sure most people here have used subnet routers in some way, shape, or form. One of the things that is most important, I think, here is that everybody's using subnet routers, but everybody is doing it in their own distinct way. And to me, the title of this webinar is scaling Tailscale. When I thought about scaling Tailscale, I actually thought about how we scale our team as well as how you scale Tailscale for your individual organization. And so one of the things that I'm going to really focus on today is that repeatability and that commoditization. We are going to have a section at the end where we talk about the things that you really need to focus on in terms of making sure Tailscale scales for your organization. But let's also talk about the use cases as well. So when it comes to repeatability, as I already mentioned, user data is our primary implementation mechanism here. You can use containers. We're going to see some container-based solutions and when you get to the next slide, but I'm not really going to focus on that specifically today. But these repeatable patterns and these easy implementation strategies are something that we see on the solutions engineering side all the time. And so what I have been doing as part of my responsibility as a community maintainer and also a Tailscale employee is building these Terraform modules that are repeatable patterns for you as users and consumers to be able to leverage all the great features of Tailscale without having to reinvent the wheel every single time you go and do something. Now, I please want to make sure this is very, very clear. These are not official Tailscale modules yet. They are currently maintained by myself. And there are lots of other wonderful Terraform modules that are focused specifically on Tailscale, but they are very use case focused. And so what I have tried to do is make these repeatable in a way that you can leverage them for your specific use case from the very get-go. And we're going to look at those two use cases now and how they've been implemented and how these modules can make your life a lot easier. So let's do a demo, my favorite thing. Please remember, I'm doing all this live. If something goes wrong, I'm going to troubleshoot it. I'm going to make this as real as possible, but please be patient with me. It is very much appreciated. Let's go and have a look at my VS Code screen here. So what I have here is the most important, like the foundational Terraform module here that is kind of registered in the Terraform registry here. So if we go and look in my organization, you've got this Tailscale module here. And if you look at the module name, it's basically LBR Labs Tailscale Cloud Init. You can see the source code here. I will make notes of all of the links to these things later. This has been implemented with most of the Terraform best practices that you would usually be familiar with. But if you're familiar with the Tailscale CLI, a lot of these different options are going to be pretty obvious in what they do. So what does this particular module actually do? Well, it implements the installation of Tailscale for your compute using all of the best practices and then templates all of the CLI options for Tailscale into the user data for you. So every single flag that is available on Tailscale up is in this module, allowing you to implement this. You can use this to set up app connectors. You can use this to set up exit nodes. You can use this to set up all of the different Tailscale use cases from a single Terraform module. Now, the other things that this is actually doing is, and we can take a look at the file here. Obviously, in order for Tailscale to work successfully, you need to have IP forwarding turned on for subnet routers. So we enable that in the operating system. And there's also a really, really important part of Tailscale when it comes to performance that is required to have the most throughput through a Tailscale device, which is a part of Linux kernel 6.2 and above. And this is UDP offloads, transport offloads, which it increases the amount of UDP throughput that you can get on your operating system. So this particular part of the Terraform module detects if you're using the correct kernel version and implements this on the correct network device for you. Again, Is this something that you wonderful, talented people that are joining today could do? Absolutely. Is this something that everybody needs to do individually and repeat the same work? I personally don't think so. So what does that look like in reality? Well, sorry, what does that look like when it comes to the actual Tailscale part? Well, these are just standard shell scripts which are templated in Terraform's language. We do a bunch of retries because if there's one thing that I've learned about cloud providers is nothing works the first time. So we have a bunch of retries in the shell script here for installing Tailscale and then also setting up Tailscale. You can see the Tailscale command here is passing all of the different possible up commands through from the templated implementation. You can see I can set the operating system, sorry, the host name here, different tags, a whole bunch of other stuff. And this has all been validated with shell check. So it all is, up to date in terms of the general best practices. I will accept pull requests for these. If you're a better shell scripter than I am, I would happily take pull requests for these. But what does this look like when you actually want to go ahead and use it? Well, this is the example that we've implemented inside the actual Terraform module. So you can see here is my user data. I'm installing this on Ubuntu. This works on Amazon Linux. It works on Red Hat. It works on CentOS. I validated all of these. And what I can do here is actually leverage any of the Tailscale CLI commands into my Terraform module without having to worry too much about having to do all the templating yourself. And you can see, obviously, I've got my Terraform, Terraform language server installed here, so it's giving me all these great options. I can then pass this to my my EC2 instance. I've also implemented this additional parts part here, which allows you to actually do any other user data stuff that you need to do on your given host as well. You can see here, I'm going to grab the AWS AMI for Ubuntu. I'm going to create a security group. I obviously want to open port 41641 for Tailscale's UDP port. And then all I have to do is pass this rendered user data through here, and we're off to the races. So what does this look like? Let's do a Terraform plan. Just a thanks while waiting for this. Thank you so much to Alan for manning the chat. I can see he's already doing a stellar job there, answering all these different questions. So here's my user data here. Let's go and decode this so you can see what the actual result is. Let's do this. And you can see what ends up happening here is that all of these different things that we need to do to make Tailscale actually viable on this machine all gets done automatically for you. Again, as a reminder, all of that shell script, all that user data shell script was implemented for you as the end user in about 10 lines of Terraform code. This is a massive improvement in terms of the amount of work that you have to do in order to scale your infrastructure. So if you want to put Tailscale on a whole bunch of other machines with user data, you can now do that really, really easily with these particular Terraform modules. So let's go ahead and apply this. You can see here as well, just to show you as an example of adding other user data, I'm also going to install the CloudWatch agent, which allows me to stream logs to CloudWatch. You can see that here. That's going to go ahead and create my AWS instance. I get to ad lib for a few minutes now because AWS doesn't value your time. So that'll go and create the instance. The user data will run, Tailscale will install, and we should be good to go from there. Let's go back here. And we're going to go into CloudWatch, and we should be able to see in CloudWatch, because I installed the user data, the CloudWatch agent, we should be able to go into log groups and look for cloud init output log. And take a look in my log group here. Here is a EC2 instance from this morning when I was doing the test here. So you can see here, all of my logs are actually going to get streamed into CloudWatch because I installed that CloudWatch agent. But you can see what it's doing. It's installing the Tailscale package via the Tailscale packages repository, unpacking the deb there. It's going to do a whole bunch of other stuff in terms of doing a Tailscale up. You'll notice here that it actually is telling me, because I ran this before I actually did the UDP forwarding stuff, because of the way that Cloud Init works, it installs those different, it does those different scripts in a different order. This is where the actual optimizations was installed, and then everything was kind of configured correctly. So any minute now, and I ad-libbed perfectly, my example client has appeared. And this is just a fairly standard client in a public subnet that has been installed with Terraform without having to do very much work on my side as a user. I really hope that we get some people kind of taking these Terraform modules for a spin. I personally have used them with a bunch of different customers now, and they seem to love the fact that they don't have to do a whole bunch of work here. If this is something that people start to use as a community module, I would really like to make these as officially supported Tailscale modules at some point in the future. So we're looking forward to the feedback that we get around these modules. Please let me know in the chat or in any other kind of format if this is something that you have already solved but you wish you hadn't solved, or you're kind of embarking on your Tailscale adventure and you want to be able to use this stuff from the get-go. I'm happy to help. Anybody who needs that kind of support and any kind of implementation. But this is the kind of base level. Again, what we've shown you so far is an individual client where we would install Tailscale directly on every single EC2 or every single piece of compute that you have defined, and allow you to use all of the different ACL mechanisms. Just as a high-level idea here, you remember, you could take a look here. I've specified the tags that I want to have on this particular client, and the tag has shown up here. I can then use my ACLs to be able to define who is allowed to access what. So I can do action accept. Help if I could spell. Source group engineers. Yes. West 22. Now, the reason that I do this is to show you, again, one of the benefits that you need to kind of think about when you're making the decision between installing Tailscale in a subnet router or installing Tailscale directly on the client. It is possible to be prescriptive with what actually happens behind the subnet router, but if you install Tailscale directly on your EC2 without a subnet router, you can be extremely specific in how much connectivity individuals have. And this is an important consideration that we ask people to think about when they're kind of when they're embarking on their Tailscale journey. These kind of mechanisms of being able to use tags at scale are really, really important. Now, this is a single instance, so this isn't really helping you understand how Tailscale would work at a large scale, but the ACL mechanism is a really important part of this. So that's an individual client. This in itself is really not useful for an end user. This isn't really a useful mechanism for most people. So what we now need to do is think about what this would look like when we're doing things on a larger scale. And in most circumstances, because of those managed services that were already mentioned earlier, subnet routers almost always come into play here. And subnet routers are important because they generally become this bottleneck or this really critical piece of infrastructure in your organization. You generally don't want to have a single instance subnet router. Like, for example, with this particular instance here, I could do advertised routes, and I could do the VPC routes. So it would be like VPC module.lbr vpc.cider block. Perfect. I now have a subnet router, right? Like with a single line of code with my user data, I have now turned this into a subnet router. But a single subnet router on an EC2 instance is really not going to be something that I consider to be production grade in most organizations, right? Because, this EC2 instance gets interrupted, or this EC2 instance is kind of moved around, you will definitely have a loss of connectivity for a single instance. So let's look a little bit at the usage of this particular user data module, but in a more production grade, highly available manner. So this is another module that I've created here. And you can see this here. This is the Tailscale subnet router in AWS. And this implementation is, again, it's using the user data here that you can already see that we've leveraged and I'm enabling SSH, and I'm setting some host names, and I'm advertising tags, and I'm advertising addresses, etc., etc., etc. All these are set as variables here in the actual module itself. Again, would love pull requests or feature requests for this particular implementation if it doesn't necessarily meet your needs. You can see that I can actually specify the max retries and the retry delay for those shell scripts that we have on the underlying user data. So I want to have 10 retries, and I want to try every 10 seconds. But this is going to create an auto-scaling group rather than a single instance. Why is that important? Well, auto-scaling groups are the first-class citizen that we generally recommend on the solutions engineering side to AWS users to make sure that their subnet routers are highly available. Of course, if you're using Azure, there is a similarly applicable implementation. But let's run Terraform apply here. This is actually going to create two subnet routers here that are highly available. They're advertising the same route. Again, this is all applicable to other cloud providers. So Azure has scale sets, so you can easily kind of implement this on the Azure side as well. This is ultimately going to create that subnet router in a auto scaling group with all of the required implementations for you to have a set of highly available subnet routers in AWS that are resilient to failure. And what I mean by that is if AWS comes along and has a hardware issue on one of these instances, or AWS comes along and terminates them for some reason, or maybe you want to use spot instances for you want to use a mixed instance policy or a spot instance so that you can have more control over costs. All these things are now available. Again, the secret sauce here is the underlying cloud init implementation that is being passed to the actual cloud provider implementation. So again, all you can see here, the actual user data that was rendered is being passed down to the launch template that is associated with this auto scaling group to actually install Tailscale and create those highly available things. So let's go and take a look in AWS. And take a look in instances. That's my previous search. So we're looking for LBR. So my subnet routers are now, as you already noted, there is two of them, so they're highly available. They are initializing, so they're likely running user data right now. And just right on time, my subnet routers have appeared. There's now two of them. They are in a highly available pair. This is really, really important for those situations and circumstances where you need to have that high availability and you need to scale Tailscale to a much larger implementation. You can see I haven't set up my auto approvers, so I'm going to manually approve these. The primary reason I didn't do that is so that you can see that it's advertising those routes. And I can now access anything that's behind this subnet router without having to worry about what happens when one of them's killed. Let's go ahead and kill one of them, which is really unfair of me because it hasn't even finished initializing yet. But I'm going to go into, I need to do this, terminate instance, let's terminate. So I still have connectivity. One of these is going to disappear. One of these highly available subnet routers is going to disappear. Terraform has already created the auto scaling group. So the auto scaling group is going to handle all of the work that is needed to bring those back into service. And this is one of the most important things that we see when it comes to customers on the solutions engineering side. They believe that they just need a single EC2 instance as a subnet router. They think that's all they really need to have to implement. And instead, what they realize is that ultimately having these in a highly available pair is really important. You can see my instance is terminated now. So I'm going to remove this because it's not any use to me at all because it's now been offline. If we go and take a look at the auto scaling group, let's take a look here. Automatic scaling activity. So it should launch a new instance any minute now. And as a result, we'll get back into that place where we have those highly available subnet routers. Of course, you would need to implement the auto scaling group in a way that is a lot more, that is kind of reactive to these different situations in terms of what your uptime looks like. bearing in mind, I still have one of these that's online, so I could still access anything that's behind this approved subnet route without any real problems here. While we're waiting for that to finish, I'd love to go back to my slides because AWS is going to take a few moments and talk a little bit about some of the common pitfalls that we see in some of these approaches. So most commonly, we get questions around performance problems. If you're not getting direct connections to any of the infrastructure that we created here, you will get latency and throughput limitations. If you're not familiar with our relay servers are something that facilitates connections between two Tailscale devices in environments with particularly tricky and hard to navigate, networks. If you are going through a relay server, you will see a notification when you run Tailscale ping, and I'm going to run Tailscale ping example client here, and because this is a public subnet, I'm getting a direct connection. However, if you do this in a private subnet, what you'll see is relayed via one of our relay servers, and that is because you can't kind of create these direct connections. So our suggestions, and we have a wonderful framework, Alan. Hopefully you can pull up our AWS reference architecture. We have AWS reference architecture that will help you get those direct connections. The next webinar that I am going to do next month, and I don't think I've told our marketing team or Tim this yet, the next webinar that I'm going to do is going to be focused specifically on direct connections and looking at all of the different types of connection and being able to debug them from the Tailscale console. So if you're excited about that, let us know in the chat. I would love to hear if you're having these issues with direct connections. But this is the most important thing when it comes to performance. Those relay servers do have limitations on them of how much latency and throughput you can get. The other thing when it comes to throughput constraints or like performance constraints is, have you tuned your operating system correctly? What do I mean by that? Well, if we go and take a look at my Terraform here, this UDP offloads stuff is really, really important to get really performant connections in certain scenarios with WireGuard Go. So you can see here, Tailscale will actually throw a link at you to tell you all about this if you are being affected by this. And you can see this takes you to a, oh my word, F2 config apps pro Tailscale. I guess I pasted the wrong link here. And look, there we go. Look, we have a GitHub issue for this. Here we are. So this here is talking about Linux optimizations for subnet routers and exit nodes. So if you do use a subnet router, you should take a look at this particular invitation. I see this regularly with my customers, that there is an issue here with the way that we have set up with not actually implementing this. I actually saw a message in our internal Slack yesterday that our wonderfully talented engineer Jordan has been working really hard on this, and this may not be needed in later Linux versions, but I'm not the expert on this, so I'm going to go and kind of ask him about that. But ultimately, taking a look at this performance best practices page is really, really important. I already mentioned the AWS reference architecture. I'm sure Alan threw it in the chat. I haven't had a chance to look, but here is a great page that's going to talk all about the different ways to implement with things with Tailscale. And one of the most important things here is instance size. Everybody is always tempted to use a T-type instance when they're running Tailscale when it comes to subnet routers or any other implementation. But take a look at this recommend instance sizing here. If you just install a Tailscale against your normal application, you should not have to worry too much. So if you're doing that first use case, when you're installing Tailscale via user data alongside an application, and the application's network needs are already being met, Tailscale will meet those needs too. However, if you are using any subnet router and you use a T-based instance, you get CPU credit mechanisms which can result in performance issues. And I would say 75% of the conversations that I have with people around performance with Tailscale are because they're using a T3 micro and they have reached the amount of CPU credits that they can use. And as a result, the encryption that's happening in the CPU via WireGuard is ultimately not keeping up with the needs, and you are getting slower throughput. The other thing, which I think is less well known, is that if you take a look at the AWS documentation, instances with less than 16 vCPUs also have a network credit mechanism. And AWS doesn't give you an easy way of looking at what that is. So one of the things that we see on a semi-regular basis, I would say it's way less common than the T3 micro or the T2 micro issue, is that they're using an instance that actually has a network I/O and they're pushing massive amounts of data through it. And so they're getting rate limited on the network side as well. It's been very rare that I've had a conversation with a customer and the performance issues that they're experiencing are actually a Tailscale issue. They generally actually happen on the actual infrastructure themselves. So when it comes to scaling Tailscale on a performance perspective, really do take a look at what you put as the underlying mechanism for your Tailscale infrastructure, and you should see massive improvements there. Getting direct connections, I already mentioned. If you're behind a managed NAT gateway and you're in a private subnet, you probably aren't going to get direct connections. I already mentioned that I'm going to do a webinar on this next month where I talk more in depth about all the different connection types. But any instance behind a managed NAT gateway is going to be in a hard NAT. And as a result, it's going to have outbound port randomization applied to it, and we can't guarantee direct connections in those situations. That is completely outside of our control. It's an AWS limitation on the managed NAT gateway implementation. And ultimately, we need to architect you into a position where you no longer have these issues. We do have plans in this space. I'm not allowed to talk about them just yet, but we do have solutions coming. But in the meantime, the solution, the primary solution here is to move these instances into a public subnet. Now, if you can't move things into a public subnet, we have an experimental implementation that you can use. And I will highlight and underline and bold that it's very experimental, that you can use a load balancer in front of those. If you are interested in that, please email us at se@tailscale.com. Hopefully, Alan, if you're listening along, you could put that email address in the chat. And we could talk a little bit about that implementation. But we aren't going to make that public just yet because we do need to make sure that we're helping you through those situations. Once you put those instances in public subnets, you also need to make sure that port UDP port 41641 is open. 41641 is the default port that is used for Tailscale D. So you may need to make sure you have security groups open, and don't forget IP tables. The number of times I've spoken to customers and like, I've opened this security group and everything's fine, and then you look at the instance and they've got IP tables running is way more than I would like to admit. So you've got to make sure that the inbound connections can come into port 41641 via UDP traffic into the operating system as well as the cloud provider. We already talked a little about the throughput constraints, this transport layer offload stuff. We already talked a little bit about. You can implement that with the script that we already mentioned in the Terraform module. And instance size, we already covered that. So just make sure you're sizing those things accordingly. I'm just going to quickly go back to my demo infrastructure here and make sure this is all done. And then I may be able to give you all some time back. I'll take a look at the questions. Let's take a look here. So my subnet router has reappeared because my auto-scaling group, we can go and take a look at my auto-scaling group's activity. So you can see here, shortly after 4 minutes after my EC2 instance went down, a new one was, this one was terminated, and it very quickly replaced this. So again, highly available subnet routers, really straightforward here. You can see my new subnet router has arrived and is now sharing traffic. So we've got that high availability. You'll also notice that I made these T3 micros, which is against everything that I just said to you, but obviously I don't want to run up Tailscale's cloud provider bill for no reason. But ultimately, I'm getting that high availability. I'm getting that capability of being able to run that traffic, large amounts of traffic, but I'm also resilient to failure as well on the subnet router side. So that's all of the content that I had today. It is getting into my evening, so I didn't plan on taking the full hour here. What I'm now going to do is take a look at some of the questions that we've got coming here. I know that Alan's been manning the chat really well, but I want to make sure that I take a look at some of the questions here. So let's take a look. How am I handling generating auth keys for the cloud init in Terraform? Right now, the way that this is handled is just passing the auth keys directly into the user data. I absolutely acknowledge that this is not the correct way to do this. So if we go and take a look, and you're all seeing my demo env there. So if you want to go and take a look at that, then please feel free. I have an open issue here, which is support secure auth keys. What I'm planning to do is implement something in the user data that will pull those auth keys from a secret provider, whether it's AWS SSM, and I'm hoping to make this cloud agnostic. This is coming in one of the next iterations of this user data. Right now, those auth keys are in plain text. I recognize that that is not acceptable for lots and lots of people, but this will be fixed in the near future in a much better way. Hopefully that answers your question, Dan. Given the latency, the next question that I had was, given the latency for EC2 ASGs, are there performance considerations in terms of network throughput to this architecture? I think I've covered that. I'm happy to kind of go through it again, but I think we talked a little bit about the network throughput. The network throughput really is dependent on the underlying hardware, right? So like AWS's network hardware, Tailscale will meet the same needs. I think there's a really great blog post, Tailscale 10 gigabytes. So there's a really great blog post, by my very talented and wonderful colleague Jordan, who works on a lot of the performance stuff here. This will give you a really great like deep dive into how Tailscale can meet these performance needs. But ultimately, the network architecture is on the cloud provider side, right? Tailscale will meet those cloud provider needs. Tailscale will meet and match the capabilities of the cloud provider based on how you have implemented the underlying infrastructure. You can see here in this blog post, there's an iPerf test here, and we're getting 3.11 gigabytes. Like we're basically saturating the network here. Hopefully that answers your question. Happy to elaborate a little bit more. I've got a question that's related to Magic DNS for Mulvad. I'm not really sure, Fabio. I'd love to get a little bit of further context there. I'm not really quite following what the features are around Mulvad. I could talk a little bit about Magic DNS. So what Magic DNS is doing is it's registering this host inside this particular DNS here. So what that means is when you register an instance in your DNS, in your tailnet, when you register your instance, you get a DNS record in Magic DNS that points to this address, so like an A record for this address. You'll also notice that because I'm a Tailscale employee, I get the really fancy Tailnet name there. That is not something that we offer to everybody, so please do not email me asking me for your own vanity name. But when we register those clients in there, you can do a NS lookup here, and let's put my money where my mouth is, and we'll do dig at 100 watt number and pull client. That has not worked, so let me do dig example client. Okay, interesting. Let's look up. Don't know why that is not resolving. There we go. So you can see here it's resolving the actual client name and the address. That's all that Magic DNS is going to do for you. It's going to give you the ability to add that client and into your DNS provider. We have some really exciting stuff coming in Magic DNS. I'm not allowed to talk about them just yet, but we have some really exciting stuff coming in Magic DNS that I'm going to be really excited to do a webinar about in future. But watch this space. We do have a SE office hours scheduled in a couple of weeks, where if you want to ask more about our product stuff and the things that are going to happen in the future, we would love to see you at the SE office hours. So this is a much more kind of ad hoc question-based type webinar. We'd love to see you there. Hopefully that helps, Fabio. I wasn't quite sure on what you were kind of getting at with the Mulvad stuff, but hopefully that gives you an answer for the Magic DNS. Marco has a couple of questions. So Marco is asking, are you planning to have a kind of include feature in the ACL files so you can have the flexibility split file in several ones so we can have easier management and more secure, because I could restrict which section devs can configure? Well, Marco, my wonderful and talented colleague and social drinking partner, Cameron Stokes, has solved this problem for you. So here is the Tailscale ACL combiner. What this allows you to do is split up your ACLs into different directories with the who JSON and actually combine these into a single JSON file that you can then apply with GitOps. So I would recommend taking a look at this particular tool. I think this is largely going to solve the problem that you just mentioned. So this is available at Tailscale Dev, Tailscale ACL Combiner, and this was put into place primarily because of this particular problem you talk about. We do have product features in the roadmap here that we're going to improve things here with this particular implementation. But in the meantime, we've got lots of customers that are using this approach and they're very, very happy with it. Marco asked him the question, we're using Magic DNS and make a DNS request, for example, dig at 100 Google.com. Which DNS provider are we using? You're actually using the 100, which is then got upstream resolvers, Marco. So ultimately, you're just using 100. If you take a look at what Tailscale is actually doing to your resolve.conf, so if we go to eccresolve.conf, and I'm on OS X, so I don't know why I'm thinking that's going to work because I'm on OS X. But if I was on a Linux box, oh no, I misspelled it. So you can actually see here that Tailscale has updated my name server to use this by default. And what this is if you go and look in DNS, you can actually have override local DNS and a whole bunch of other stuff here. That's ultimately what's happening with the DNS entries. So you can add multiple resolvers here. You can manage this yourself, or you can allow Tailscale to do it for you. Sean has a question. We see a lot of packet loss when we are streaming video from a NUC installed router to AWS EC2 instance. How can we prevent this? I will be honest, I'm not entirely sure what would be causing that without digging a little deeper. Packet loss on the Tailscale level is generally caused either by relay connections or, and that's very rare because the relay is a TCP proxy almost for a lot of those traffic, or it's likely due to something at your network level. Again, Tailscale is going to use that network level. I would really encourage you, Sean, to send an email to our support team with a little bit more information. You can use something called Tailscale Bug Report, which will generate a bug report that will get sent to us, and that will allow us to give a little bit more information. So I would generally recommend running a bug report, attaching the bug report ID to support@tailscale.com. Our support team is wonderful. They should be able to help you a little bit more there. Without actually being able to see more about your infrastructure and implementation, it's really hard to understand what that might be. Grayson has how can you describe it? You can use Magic DNS with Warp and how Warp impacts Tailscale. I'm assuming that is Cloudflare Warp. Guessing. Our recommendation with Tailscale is to not use other VPNs locally, and Warp is essentially a VPN, even though it doesn't kind of pitch itself as that. So I'm not super familiar with Cloudflare Warp myself. If you want to email se@tailscale.com to kind of give more information, Grayson and Fabio, on what you're planning to do with Tailscale, we can give you a little bit more information about what that would look like with Warp. I personally have not used Warp for a very long time, so I don't know what that would actually look like, I'm afraid. Okay, that's a lot of talking. I've done a lot of talking. So I want to give everyone else one last opportunity to ask any other questions they might have in our Q&A. And if not, I'd love to give everyone about 10 minutes back. Oh, okay. So you're using the Warp shell. Okay. Yes, I am using the Warp shell. Okay, that makes sense. I'm now reading the chat. I am using the Warp shell. I love it. It's great. It gives me a whole bunch of capabilities. But yes, that's ultimately it should work with Warp just as any other thing. Okay. Appreciate everybody's time. Thank you so much for everybody joining today, whether it's late in your evening or whether it's early or whether it's in the US. Really appreciate the great attendance. Like I said, we do have another SE office hours coming up in a couple of weeks, which is a lot more casual. They're going to be myself and my wonderful colleague Jay will be there. We're going to take your questions. We're going to talk a little bit about some product stuff. We're going to talk a little bit about all the different ways that Tailscale can help you. But that's a forum for you folks that are listening in to have the opportunity to ask those questions. So come with your questions, come with your problems. We will try to solve them live, or maybe you can just stump us. So yeah, really appreciate everybody's time. Thank you so much. I'm going to stop the recording and end the webinar, and I hope everyone has a wonderful day.